Okay, so now we're going to discuss special right triangles. And if you look on the back of your reference sheet, next to the trigonometric ratios to the left of it, you're going to see a title that says special right triangles, and you're going to see two triangles here. Let's start off with the 454590 triangle, also known as an isosceles right triangle. Well, why is it called an isosceles right triangle? Well, it's called isosceles because both of the legs are going to be congruent. And if you remember, we said that there is a relationship between an angle and the side that is across from that angle. So this 45 degrees here is across from this side of x here, and this 45 degrees is across from this side here. And since both of these angles are congruent, then these legs, which are across from the angles, will also be congruent. And what I have here is an isosceles right triangle. Both legs are congruent, and here is my 90 degrees. Well, why is it special, or why is this a special triangle, let's just say? Well, for one, in order to find the sides of a right triangle, usually you need two numbers in order to use the Pythagorean theorem. But with a special right triangle, we don't have that issue because we know that the rule tells us that the two legs are going to be congruent, and no matter what the legs are, the hypotenuse is going to be the same leg, times the square root of 2. So let's take a look here. Here I have an isosceles right triangle. I know that it's isosceles because both of these legs have congruency marks, and I have a 90-degree angle here. Usually, if I wanted to find some other sides of this triangle, I would have to use the Pythagorean theorem. But unfortunately, all I have here is one leg, so I can't use the Pythagorean theorem. However, I do know that this is an isosceles right triangle, meaning that what? That the legs are congruent. So if this leg is 3, well then this leg here is also going to be 3. And I don't even have to go through the trouble of using the Pythagorean theorem. I can even find this third leg here just by looking at my diagram. The rule for isosceles right triangles tells me that the hypotenuse will always be the leg x times the square root of 2. Well, here my two legs are 3, so my hypotenuse is going to be 3 times the square root of 2. Now, in case you don't believe me and this doesn't make any sense to you, I took the liberty of doing the Pythagorean theorem here. These are my two legs. This is my hypotenuse. So in theory, a squared plus b squared should give me the hypotenuse of c squared. So I worked it out here. I have 3 squared plus 3 squared is going to give me c squared. 3 to the second power is 9, and 3 to the second power is 9, and 9 plus 9 is equal to 18, and that's equal to c squared. Well, now I want to find the square root of c, right? So I take the square root of both, and here's my calculator. Here is 18. I shift the square root, and I get 4.24. So the square root of 18 comes out to be 4.24. So the hypotenuse is equal to 4.24. Now you might be saying to yourself, wait a minute, Mr. C, you said that should be equal to 4.24. That doesn't look like 4.24 to me. Well, remember, this is just 3 times the square root of 2, right? So here's my calculator. Here is 2. I'm going to take the square root of 2, which is 1.41. I'm going to multiply it times 3, and what do I get? 4.24. This is just writing 4.24 in a different way. But if you notice here, it's exactly the same thing. So my question to you is, would you want to go through all the trouble of actually doing the Pythagorean theorem? Or would you want to look at your reference sheet and just be able to say, oh, that's a 45, 45, 90 triangle. I know the legs are going to be the same, and the hypotenuse is going to be 3 times the square root of 2. It's going to be the same as the leg times the square root of 2. Let's take a look at another example. Well, here I have a right triangle. They give me one angle is 45. I know it's a special right triangle because in a triangle I have 180 degrees. So if I take 180 minus the 90 degrees that I'm using here, minus 90, leaves me with 90 degrees, minus the 45 degrees that I'm using there, whoops, hold on a second, 180 minus 90, leaves me with 90, right, minus the 45 degrees that I have there. What do I have left? I have left another 45 degrees there because it equals up to 180. So I already know that this is going to be an isosceles right triangle. Well, now that I have that information, I can figure out all of the other sides. The diagram shows me that the both legs are congruent, and that happens because we have congruency dashes here, so this is also going to be 42. And I don't have to waste any time using the Pythagorean theorem. I know that the hypotenuse is going to be 42 times the square root of 2. And if you actually worked out the Pythagorean theorem and worked these out, you'd probably get whatever this is equal to in a calculator. Similarly enough, if they give me the hypotenuse, well, here they're giving it to me, and the hypotenuse says that the rule says that the hypotenuse is the leg times the square root of 2. Well, here it is. Here's my leg times the square root of 2, which means that both of my legs are going to be 5. And that's just a simple breakdown and a quick explanation of an isosceles right triangle. However, there are some gotcha questions that we need to watch out for. And let's discuss those questions right now. So I'm looking at this triangle here, and I know that it's an isosceles right triangle, and they give me the hypotenuse. And okay, my hypotenuse is 4. But when you look at the diagram of an isosceles triangle, what does the diagram show you? It shows you the leg times the square root of 2. When I look here, there is no square root of 2 next to it. The reason for that is that it's already been multiplied in there. Remember that the legs are x, and that the hypotenuse is going to be x times the square root of 2. So they took the x already, and they multiplied it times the square root of 2, and what they got as an answer was 4. So here's what I'm going to do. I'm going to show you a shortcut that you don't have to deal with square roots or radicals or anything of that sort, because there's a lot of rules that go into that. I'm going to show you a quick shortcut for this question. If you have an isosceles right triangle and they give you the hypotenuse, but it doesn't have the square root of 2 next to it, that means that the square root of 2 has already been multiplied in there. So the legs, here's the shortcut. The legs are going to be half of the hypotenuse. And they're both going to be times the square root of 2. So when they give you a hypotenuse and there is no square root of 2 next to it, the legs, the shortcut is the legs are going to be half the hypotenuse times the square root of 2. Let's take a look at another example. So if here I have a 454590 triangle, obviously my right angle is pointing me that this is the hypotenuse. I'm accustomed to seeing what next to the hypotenuse? The square root of 2. There's nothing there. There's nothing there, which means that the square root of 2 has been multiplied into my hypotenuse. So now I'm going to take the shortcut that I learned. Okay? The shortcut tells me that in a 454590, the legs are half the hypotenuse times the square root of 2. So what's half of 8? Well, it's going to be 4 and 4. And the legs are going to be times the square root of 2. And trust me, if you did the Pythagorean theorem with these two, you would get 8. But you don't want to go through all that trouble. Let's take a look at another example. Here I have a triangle. I know that this is 90 degrees. I know this is 45 degrees. So when I add them and subtract from 180, yeah, I know that's going to be 45 degrees as well. So I know I have a 454590 or an isosceles right triangle. I know that this is my hypotenuse. Notice that there is no what? There is no square root of 2 next to it. Notice that there is no square root of 2 next to it. So my legs are going to be half, which are going to be 3 and 3, and I'm going to multiply them times the square root of 2. Okay? So when they give me my right triangle, and it's 5 times the square root of 2 is the hypotenuse, well then I know the legs are just going to be what? 5 and 5, because I can see that from the diagram here. But the gotcha question is that a lot of times they like to show you the hypotenuse with no square root of 2, trying to trip you up. And the shortcut to that is that the legs are going to be half of the hypotenuse times the square root of 2. Now let me give you another gotcha question for you to think about for a second. Take a look at this question here for a second. It's a 45-45-90 triangle. It's an isosceles triangle. What do you think the hypotenuse is going to be? I'll give you a minute to think about that and work it out. Well, if you remember from the diagram, The diagram shows us on our reference sheet, where is it? Here it goes, that the hypotenuse is always the same as the legs, and they get multiplied times what? Times the square root of 2. Well, here, my legs are these, right? So whatever my leg is, 3 times the square root of 2, those are my legs. That's going to be multiplied times the square root of 2. Because the rule tells us that the hypotenuse is the legs, x and x, times the square root of 2. Except that here, my legs happen to already have a square root of 2 next to them. So those are my legs. Well, after here, it's pretty simple. Because I know that the square root of 2 times the square root of 2 is the square root of 4. So I'm going to have 3 times the square root of 4. I know that square root of 4 is a perfect square, so that's going to be 3 times 2. And 3 times 2 is equal to 6.